Hello! In this in-class activity, we are going to learn how to obtain measures of central tendency, the mean, the median, and the mode. First, let's look at the mean. Question 1. Find the mean hourly income for 3 workers. So we have hourly pay for 3 workers. When you read the class material, you know that this is the sample formula we use to calculate the sample mean. You plug in the 3 numbers and you sum them up and divide it by 3, and you obtain the mean value 20. So the calculation is straightforward. We know the mean value can be profoundly affected by the extremely large or extremely small value. For the first data set, we have a very small value 0. Okay. When we bring that 0 into the calculation of mean, you obtain a very different mean value 15 compared with 20 we obtained in question 1. This is a 25% drop. Okay. In the second data set, you have an extremely large value. When you bring that extremely large value into the calculation of the mean, now the mean becomes really large. So that really showed that the mean can be affected by the extremely large or strong or small value. The reason is that when you calculate the mean, you have to bring all values into the data set. Those extreme values may have profound impact on the outcome of calculations. So far, we've been dealing with only one variable. Also, we did not use any visual device to show the position of the mean visually. Now, I'd like to extend the concept of the mean into situations with more than one variable. Also, we'd like to use some visual device to show the position of the mean. Okay. So that's why we have the mean center and the geographical center. Now let's start with the simple situation with only one variable x. With this 3 value of the variable, we can first calculate the mean 11.7. Now we have this one-dimensional space, and this is called the number line. The number line is made in such a way that the smaller values are on the left and larger values are on the right. And with the mean value 11.7, we can, this is starting point 0. You can find somewhere along the line here that the 11.7 is located. You make mark there with a right dot and label that right dot with 11.7, the mean value. And that's how we visually express the position of the mean. Now we extend the concept of mean into two variable situation and a two-dimensional space. Now we have a 2 variable x and y. We can calculate the mean for both variables, 11.7 for x and 23.3 for y. Now in this two-dimensional space here, this is called x-y coordinate system. Okay. They are formed by 2 dimensions. You have an x-axis and y-axis. X-axis is the horizontal axis, y-axis is the vertical axis. On both axes, we first find the respective mean position from these 2 variables. this marks the mean position for x, and this marks the mean position for y. We label them. After that, we kind of extend this mean position into x and y space to find a point here, somewhere there. Now, this point simultaneously express the mean of x and the mean of y. Now, we label this point by putting in the mean of x and the mean of y within these parentheses, and these two values are called the coordinates, x coordinates and y coordinates. These two mean values are simultaneously expressed by this point in this x, y two-dimensional space. So this point has a name. It's called mean center. So the mean center is a point that simultaneously express the mean values of the two variables in a two-dimensional space. Now, so far, we do not specifically say what this x and y variables means. Now, for example, let's say that it happens that x and y have concrete meanings. These two variables have concrete meanings. X expressed distance east-west direction, and y expressed distance north and south direction. The unit are either miles or either latitude, longitude. Either way, now the x and y has concrete meaning. They are geographical measures. They are geographical measures. Therefore, the mean center now has another name. It's called the geographical center. So the geographical center is the mean center when on a two-dimensional space, the two variables has geographical meanings. Okay. Now we extend the concept of a mean center into the three-variable situation and three-dimensional space. With three variables, we can first calculate the mean for all three variables, x, y, and z. Now we have a three-dimensional space. It is a convention that when you have a three-dimensional space, you use the vertical axis to express the z axis. Okay. Now, on three dimensions, on three axes, you find their respective mean position. This is 11.7 for mean x, 23.3 for mean y, and for z, the mean is 6, and 6 is somewhere here. On a three-dimensional space, it's not easy to visualize. Therefore, I will add some lines to make it appear to be three-dimensional, so we can see it easily. After all these lines are added, you can really see that this spot, the spot right there, that spot is a point where we can see that the mean from three axes are simultaneously expressed. Okay. And that point is labeled by the coordinates on three axes. The order is x, y, and z coordinates. And again, this point is called the mean center. So the mean center here simultaneously express the means of the three dimensions. Okay. The median. We know median is a data point which divide a data set into two equal halves. Now, with this particular variable x, the way to find median is straightforward. We first sort all these values in descending order or ascending order. Okay, let's rearrange this variable in a ascending order. Now we find the median value. The value is right in the middle, and 7.1 and 7.1 divide the variable into two equal halves. On both sides of a 7.1, you have equal number of cases. So the median for this variable is 7.1. Now we have odd number of cases. What if we have an even number of cases here, like this? Again, we first rearrange the variables in ascending order. Then the middle two values, 7.1 and 8.0, we find the mean. We find the mean of the middle two values. And if you do a little bit of calculation, you will find the mean of 7.1 and 8 is 7.55. So the median in this case is 7.55. Previously, we said that the mean is profoundly influenced by the extreme values in a data set, but for median is not the case. For example, here in the first variable, the median is 6.7. For the second variable, you have extreme values, very large, very small values, but the median is still 6.7. So the median is not affected by the extreme values. It's not the same as in the situation of the mean, which is affected by the extreme values. The mode. We know the mode is the most frequently occurring value or case in a data set. For the first data set, you have these several numbers. Now, which number occurred at the highest frequency? 7.1 occurred only once, 5.5 occurred only once, 8.0 occurred twice, 4.3 occurred only once, 10 occurs only once. Therefore, only 8 occur at the frequency higher than 1. Therefore, the value 8 is the mode of this data set. For the second case, you have a result of a voting from several voters, and you have 4 people vote for Republican, 5 people vote for Democratic. Therefore, Democratic is the mode of data set 2. In the third data set, you have color balls, you have red balls, green balls, blue balls, and the yellow balls. Now, which color occurred at the highest frequency? As you can count, red ball occurred 3 times, green ball occurred 3 times, a blue ball occurred 3 times, a yellow ball occurs only once. Therefore, the mode for this data set is 3 colors: red ball, green ball, and blue ball. So you have 3 modes for this data set. I hope this helps. I see you next time. Goodbye.